Hey there everybody, welcome to the video Data Analysis 2. So I think it's time to have some fun, don't you? Don't we need some fun in these quarantine times? So I think it is time for us to get serious about this data analysis stuff and to quit messing around with toy, small examples, right? Let's think about real data coming from real spreadsheets. So let's do everything we did last time with these commands like .describe and data slicing and so on, but let's do it with actual data, not this tiny little example that we built ourselves inside of JupyterLab. And also I want to show you in this video how to take a data frame you already have or a spreadsheet you already have and add more information to it, where that information you add can be easily gotten from what's already inside the data frame. So this will become clear when we need it, but basically sometimes spreadsheets don't come equipped with all the data you want, but you can pretty easily create a new column yourself inside the spreadsheet, and that new column maybe is easily calculated from data that's already inside the spreadsheet. Okay, so first and foremost, let's talk about getting a spreadsheet into pandas, into JupyterLab. As always, I assume that your spreadsheets are on the desktop. I just do that for the sake of consistency and for the sake of ease. If you want to keep your spreadsheet somewhere else and you want me to show you how to grab them from somewhere else, I'm happy to do that. I am not trying to clutter your desktops. I just want consistency in what I write. So suppose that on your desktop you have a spreadsheet called all caps demographics.csv. The way that you have pandas eat that and process it as a data frame is like this. This command here, so PD for pandas, read CSV. What that does is that grabs that CSV file and processes it as a data frame. So here's the file you're asking it to process. After pandas has eaten and processed this spreadsheet here, you can then control the name of where it's saved. So on the left-hand side of this equals, that's where you're putting that spreadsheet as a data frame inside of your program. This is a variable name here, so you control this. So you can call this lowercase demographics or my data frame or whatever. It doesn't matter what you call it. Anyway, all I'm saying is that what's on the left-hand side of this equals, this demographics lowercase right here, that is this spreadsheet. It's like the same thing on some level. It's this spreadsheet that's been processed and cleaned up in such a way that your program can handle it. Your program now knows what this spreadsheet, all caps demographics, is. So speaking of the spreadsheet, you should have access to this through Moodle. This is a spreadsheet that I got from the CDC website. It's part of the Community Health Survey Index or something. I forget the exact acronym. This spreadsheet here is basic demographic information for the United States that is broken down by county. So every single county in the US has a line in the spreadsheet, and this is just basic demographic data like the population size of a given county, population density. So don't worry about what this number means exactly. It's just the bigger the number is, the more dense the county is. All these other numbers over here, these are all percentages. So this Tayuga, Alabama, its poverty rate is 10.4%. So roughly 5,000 of these people live below the poverty line. Roughly 80.7 of those people are white, and so on. So this is the spreadsheet we're going to play around with. I should say real quick, the reason that this spreadsheet is from the CDC, you might notice here there's nothing about diseases in the spreadsheet. The CDC, though, has lots of other public data sets like this that do involve diseases, or more broadly, health issues. So they have spreadsheets that have infant mortality rate, heart disease problem rates, things like this, right? So armed with those other spreadsheets, you can take this basic demographic data and try to correlate it against the health data. You could ask, is poverty correlated with heart problems or whatever? So anyway, I grabbed this from the CDC, and that's why this spreadsheet is on the CDC's website. So armed with this spreadsheet, there are all sorts of questions you might want to answer. And as always with data analysis, the questions that you want to answer are up to you. It just depends on why you're looking at this data. What particular work are you trying to get done, So if you're a demographer or a sociologist or a epidemiologist, right, your purposes might be different. So anyway, it's not like there are just questions to answer, as the title of the slide implies. I just came up with 4 questions to ask just to play around with the data set. So the 4 questions are: how many counties are there in the U.S.? This question is easily Googleable, but anyway, we're just going to play around with the data set. Which counties have the worst poverty? Which states have the worst poverty? And which counties are like the youngest? Okay, so let's think about how to answer questions like this. So I'm going to hop over to Jupyter Lab. I should say real quick that I've tried making this video several times and I keep butchering the typing of the code. So to save myself from butchering of typing, I have preloaded all of the cells that I need so that I don't butcher the typing and waste everybody's time through that. So anyway, only the first 2 cells have been run here. So I imported pandas as PD. I read in demographics all caps.csv as a data frame. I called it demo just to shorten the name. Okay, so now I'm going to start just running some commands from last time. So this demo.head, that's in the 3rd cell. If I run that, notice it shows you the top 5 lines of the data frame, just like it did in the previous video, right? And notice what it shows you. It shows you that spreadsheet, right? Here is that spreadsheet. You can scroll back and forth, you know. It's there. It was eaten. And now it is a data frame, a pandas data frame inside your program, so you can start hitting it with pandas commands, like a .head. Okay, so I'm going to start hitting it with pandas commands in a second. This next cell, let me just show you this. So if you think about the kind of data provided to you in the spreadsheet, on the previous slide, I had several questions listed, and 2 of them had to do with poverty, right? Investigating poverty. So this demo spreadsheet has the population size of a given county, a poverty rate of a given county. But notice if you scroll, there's no column that just gives you the number of people in poverty by county, right? You have population size, you have population rate, but nowhere in the data frame do you just have the raw numbers. Well, the raw numbers might come in handy. You know, you might want to know, like in this county, just how many people are there living in poverty? What about this county, and so on? So what I'm saying is you have the power, though. If you want that information, you can create a new column. And this command here is doing that, demo, and then you put the square braces, and then you name the new column. So here I've named it, number in poverty. How do you know the number of people in poverty? Well, basically, you have to take the number from the poverty column and then convert it to a decimal. So you need to be thinking of this as 0.104, and you do that by dividing by 100. And then you multiply by this population size number. That's how you would get just the raw number of people living in poverty. So that's what I'm telling it here. I'm saying, hey, create a new column, and it's called this. And how do you get that new column? Well, you take this column here, the poverty column, divide it by 100 to think of it as a decimal, and multiply by population size. So if I do that, now let me do the head command again. The head command again just shows you the top 5 lines. It looks the same as the old one, right? The old one is still here. It looks the same. However, if I scroll all the way over to the right, what do I see? I see a column here called number in poverty, right? So I just created that. I created it from 2 previously existing columns. So anyway, when I was saying back in the slides that you can add information to a data frame given some information inside the data frame already, this is what I'm talking about. You can do little things like this. Create your own columns that are obtained from columns that already existed in there. Okay, so anyway, let's move on to some other commands from the previous video. .describe. Right, what was that command? That was just you handed a data frame, and the .describe command just tries to tell you what it thinks about that data frame. Like, hey, give me a description. What do you think, pandas? And if I run that, notice it tells me a bunch of stuff. Like basically every column, it gives me some information about, and the information is like the minimum number, the maximum number in the column, a count of the number of things in the column, the mean value, and so on. So for example, let's think about population size. Population size. Let me first say, if you are confused by this notation here, I don't know why Python decides this column will be displayed like that and the other ones won't. If you see an E plus 03, what that means is take that decimal point and move it to the right 3 spots. So I get 3141. If you see like an E plus 04, it means move it to the right 4. So I move that to the right 4 and I get 94,368. Anyway, the number of population sizes in the file was 3,141. That means there are 3,141 counties. So our first question from that slide was, how many counties are there? We know that for free from this .describe thing. And notice that 3141 is consistent across all the columns, right? Because that's just a count of the number of things inside each column. And the columns all had the same length because the number of counties is all the same. Okay, there are lots of other things you can start learning from this. Like you can learn, okay, so check this out. The minimum population size, E plus 01, means move the decimal point to the right by 1. So there is a county in the U.S. With 62 people in it. Sorry, I should have mentioned this earlier. This data is from 2010. So it's fairly recent, but a bit out of date. So maybe right now that county has grown to like 72 people. Who knows, right? But in 2010, there was a county with 62 people. The maximum size was, okay, I got to take this number and move the decimal to the right by 6. So 1, 2, 3, 4, 5, 6. So the biggest county in the U.S. had almost 10 million people. So county sizes ranged from 62 people to about 10 million people back in 2010. Okay, so as you scan your eyes through this, hopefully something on what's on the screen now jumps out at you as sort of weird. And in particular, if you're thinking about poverty, something in the poverty column should look weird to you. What is this negative 2,000 thing doing here? Right? Because the poverty column, what did it give you? It gave you a poverty rate, like 10% or whatever, live in poverty. It doesn't make any sense for negative 2,000% of your population to live in poverty. So this nonsensical number here illustrates a very important lesson about grabbing data from other people. If you're going to grab other people's data, which I did, I grabbed data from the CDC, you have to be extremely careful about doing that. And all of the good data sets out there come with some sort of documentation explaining what is in their spreadsheets. So in this particular case, I read the documentation for you, so you didn't have to. So I read the documentation and I learned that, oh, some counties they actually didn't have data for. Okay, there were some counties where they just didn't know what the poverty rate was, but they didn't want to leave that cell of the spreadsheet empty, so instead they threw this nonsensical number in there of negative 2,222. Okay, so that's what that means. So what that means for us practically is that actually right now we don't know what the minimum poverty rate is in the country. We don't know what the minimum county number would be because of this nonsense number here. Okay, so speaking of that nonsense number, what if you want to investigate poverty in the U.S. and now you're aware that, oh, some of the poverty entries are garbage because the data is missing? How would you handle that? You can do a little data slicing command like this. Check this out, right? So this is just like from the last video. Suppose you want to slice out from the demographics data frame only poverty rates that make sense. So poverty rates that are 0 or above. This kind of command here will do it. And again, this is just like the data slicing from the last video. Go inside the data frame, demo. And when you're in there, make sure the demo poverty rate is at least 0. So let me run that. So that's now run. So let me now show you demo underscore poverty.head. So it'll show you the top 5 lines. So demo POV, what does that look like? It looks basically like demo, right? This doesn't look any different really. At least the top 5 lines don't look any different. Notice the number in poverty column is still there, right? Why does this look the same as the original demo guy? The reason is because the top 5 lines of demo didn't have any issues with their poverty rates. There was no nonsense there. But somewhere inside of demo, there was this nonsensical poverty number, and we have cut it out. So to prove that to you, let me now describe demo poverty. Look at the poverty column now. It tells you the minimum poverty number is 2.2%. So of the counties in which we have data, the minimum poverty rate was 2.2%. So it is, of course, possible that there's a county out there with a poverty rate less than that, but we don't know about it. based on the data we have, the minimum poverty rate is 2.2%. Okay, so anyway, so here's some like just data slicing from last time, right? I just wanted to show you some of the stuff from last time, but with a real data sheet, real data set. So here's why you might want to slice, right? You might want to slice out nonsense or slice out missing data or whatever. Okay, so now let me move on to the next thing. Oh, yes. So what if you wanted to know the top 5 most impoverished counties in the U.S.? How would you figure that out? Well, you'd want to sort by poverty. You'd want to take this entire thing here, right? Oh, sorry, not this. This entire spreadsheet here and sort by poverty. Then you could just see what are like the most impoverished or least impoverished, depending on how you sort. You can sort from smallest to biggest or biggest to smallest. So this command here, I just stole directly from the last video. I had to change df to demo_POV, right? But whatever. So demo2, what is that going to be? That's going to be a data frame that has the same information as demo poverty, but where we've sorted by poverty level. And it's not going to be ascending. It's going to be descending. So it's going to be from biggest to smallest. So now if I do .head10, it'll show me the 10 most impoverished counties according to this data. So County Star, Texas is the most impoverished county according to this data. 36.2% live in poverty. And then the top 10 is rounded out by County Hidalgo, Texas, with 31% poverty. I should say real quick that based on my reading of this data set, this data from the CDC is extremely good when it comes to health indicators. I've read that when it comes to these poverty rates, they've actually probably undershot the data some. So these numbers might be too low, and there might be counties that actually surpass these. So you'd have to go to like the census data to really see. So anyway, you got to take these poverty numbers with a grain of salt, but we're just playing here, right? We're not trying to like write a paper based on this information. Anyway, so the top 5 counties according to our data, 3 of them are in South Dakota. Like, what's the deal with that, you know? So the nice thing about this kind of data is that as soon as you ask, what's the deal with that, right, you can maybe start seeing from the demographics, right? So, okay, so 2, 4, and 5. Let me scroll over and let's look at the demographics. 2, 4, and 5. What do you notice, right? You notice that the Native American percentage of the population is extremely high, right? So what must be happening is that these impoverished counties are the ones with like the reservations on them, right? So the Native American populations in many places never recovered from the way they were treated, right? Those places are like economically depressed because of their treatment by basically the U.S. federal government, right? Historically. Anyway, so you can start to see things like that through these data frames. That's pretty nice. If you want, by the way, to see the least impoverished counties, top 10 of those, you can just sort by ascending. So take that ascending equals false out of there. And we already knew the minimum number was 2.2. Now we know where that is. That's in Douglas, Colorado. And so on. You can just see the list, right? Kendall, Illinois rounds out the bottom 10, I guess, right? Okay, so moving on to the next question real quick here. One of the questions I asked on the slides was, what are the poverty rates by state? Okay, so this information we're getting here, these are poverty rates by county. So if you want to know like the top 5 or worst 5 counties, you can get that from this data. But what about the states? Like, does Alabama have a higher poverty rate than Mississippi, or does Missouri have a higher poverty rate than South Dakota, whatever, right? How do you answer a question like that? That question is a little harder to answer because, again, let me go back to the original spreadsheet. The original spreadsheet, all the data is at the county level, right? We don't have state level data. However, since we have the county level data, how could we get the state data? If you want to know, let's say, Alabama's poverty rate, how would you figure that out? Well, you need to know 2 things, don't you? You need to know the total number of people in Alabama that live in poverty. You also need to know the total number of people that live in Alabama. So you need to know the population of impoverished people in Alabama, and then you would divide that by the population of Alabama. You don't have those numbers directly, but you have them indirectly, right? Because you have population numbers by county, and because of our first little move inside this notebook, we also have the number of people in poverty by county. So if you want to get Alabama's poverty rate, what do you need to do? You need to add up these numbers. That would give you the, across all the counties, that would give you the total number of people living in poverty. You also need to add up these numbers to give you the total population of Alabama. And you need to do this for every state within each state. So when you're doing this thing, you need to group by state. And here we see that group by command coming back to be of some use to us. So my next cell here, again, I kept mistyping these things before and wasting everybody's time. So I have this pre-typed here. This is just like from the previous video. I'm going to create a second data frame. And again, you can call these things whatever you want. I just grabbed the stuff from the last video. Now, though, I'm going to go inside the data frame that deals with poverty. So demo poverty. I'm going to group all the data by state. So I'm going to look within Alabama, within Texas, within whatever, right? And the first thing I'm going to do is add up the population size. So I'm going to run that. And now I just want to show you what this data frame is real quick. So I'm going to add an empty cell beneath this cell 14 here. The way you can add an empty cell or a new cell beneath is you can hold escape B. And notice I got an empty cell I can type in here. So let me just look at DF2. I'm going to look at maybe the top 10 of them. Let me just show you what this data frame looks like. Isn't that nice? It grouped everything by state. You told it you cared about population size and you wanted it to add those up. So it went to the state of Alabama. It added up all the populations of all the counties to give you a total population of Alabama of what, like 4.6 million or something? And again, this number might not be the actual population size of Alabama because we had some county level data missing. We're only dealing with counties where we knew the poverty rate. But anyway, this looks about right. I mean, Alabama has roughly 5 million people or less. I don't know. Alaska has less than 1 million people. So we probably didn't lose a whole lot by doing this. California does have like 36 million people. That's what's here. Anyway, so we created the second data frame that had this population of state data that we cared about. Now we can create a third data frame that doesn't care about total population of the county, but the number in poverty per county. So DF3. Let me again add an empty cell and just show you what DF3 looks like. Do maybe a top 5. Okay, so here is just the number of people in Alabama that live in poverty. So there's roughly 700,000 of them. In Alaska, roughly 65,000 and so on, right? So I have now two separate data frames. I have data frame 2, which has total population size of every state. I have another data frame 3, which has the number of people living in poverty by state. Now, what do you need to do? You need to take this number in poverty column and divide by the total population. So I'm going to do that, and I'm just going to use the same kind of command from earlier. I'm going to go inside data frame 3 and add a new column. And that new column is going to be number in poverty, and that data comes from data frame 3. Right, this is DF3 here. I'm going to divide by population size. That information comes from data frame 2. So I'm going to run that. So now data frame 3 has a new column over here called poverty rate. So I'm going to sort data frame 3 by that. I'm going to do it from biggest to smallest, I guess, and just show you the result. Isn't that nice? This is now data frame 3, where, so again, this line here, 18, created a new column called poverty rate. And then the next line just sorted by that. So according to this data, Mississippi has the highest poverty rate, followed by Louisiana. I was pretty surprised by this. DC has a ton of money sloshing around, right? So it also has a lot of homeless people, though. So I suppose DC is just like a microcosm of income inequality or something, right? So it has both a ton of rich people making money in ways that are not clear to me, but seem clearly unethical and illegal a lot of times, but also a lot of poverty. So anyway, is Missouri on here somewhere? Let's find Missouri. Right there. Okay, Missouri. Clocking in just below Idaho. Okay, so anyway, this is the kinds of things you can do with pandas. Isn't this nice? I mean, it gives you a lot of power, right? And it doesn't require a ton of like what I would call hard programming skills, because we're just going to use these built-in functions, right? These built-in things that other people have done. So we didn't have to think through an algorithm for sorting, right? Somebody else has done that for us. We just have to know this command exists. Okay, so for the sake of time here, oh, I lost my slides. For the sake of time, I had one more question on the slide that I was going to answer. You can answer it exactly with this code that's already here. You just change, I forget what the question was, but you go to one of these cells and just change one of the names. So anyway, hopefully this was some use to you and showed you some of the power for real that pandas has, right? Power with real data.